All right, sounds good. Hey everyone, welcome to Lightning UX Flows. So the goal of this presentation is to understand how to build and construct Lightning user experience flows for applications. So earlier today we covered the primitives of Lightning applications and some of the awesome examples that applications use. These are kind of like patterns that you'll see all throughout different Lightning applications using invoices or charges, as we call it at Zebedee, static charges or LNURL pays, lightning addresses, LNURL withdrawals, key send. Um, yeah, so now let's tell a story with those primitives in terms of like how users will engage and interact with your application, as well as like how you'll build the user interfaces to handle those experiences. So in this presentation, we'll be building the user interface or designing them, discussing them. I'm using a set of components from Bootstrap. So I included the link to this slide deck in the Telegram chat already. So you can click these links. There's also a tutorial. So if you're interested in learning how to utilize this for like your hackathon, it'll automatically give you pre-built components as well as like responsive components. So then it'll work on mobile, tablet, and desktop for the web. So it's quite nice for that. So if you want to watch the tutorial, it's like an hour long. And if you want to jump straight ahead to the documentation, you can as well. So let's go ahead and get started and take a look at our designs. So here you'll see like the cover image. On the left-hand side, you'll see all the different pages as well. And then I've denoted red is for like money going out of your wallet. And then for green is money like going into your wallet. So I just want to preface that. If you see red color on the title, that means like money's leaving your wallet. And then if you see green, it's money going into your wallet. So just wanted to preface that. And then we'll look at the different user experiences organized by each Lightning primitive. So here at the top, you can see with the dashes, it's for Lightning address. We have for LNURL pay or static charges. We have for LNURL withdrawals, as well as Bolt 11 invoices. So here, taking a look into like the design paradigm, we have the Lightning address. Let me add this and open this up in the browser so it'll be easier to see. Okay, so here like you'll design a user interface to have your backend handle these properties. So for example, you'll need to accept a Lightning address, an amount, and a comment as an example. So when the user hits submit, you can actually get these properties on the backend, and then based on the response, you'll know whether or not the hitting the endpoint was successful or if it failed. So it can fail for a few different reasons. You may not have funds in your developer wallet. The user limits can be too low or too high, depending upon the Lightning address. And there may not be a route to complete the payment. So these are just a couple of reasons why the payment could fail or why you may not be able to successfully hit the endpoint. So when you actually hit submit, you're getting these properties, and then you're making a request to the API and processing the payment. And then based on whether or not that was successful, you can show like a toast to say, yes, this Lightning address payment was successful, have the user check their wallet balance to determine whether or not it was good to go, or if they received it. And then if not, you can return the error that was returned from the API. So then you can say, okay, there was an error message, and this is why your payment failed, essentially. And the API will actually return this back to you. So if you want to follow along with like technical hints on like how you would integrate this into the API as an example, or what that might look like in terms of like a step-by-step flow, this is how you would actually build out the business logic of your application. And I'll be showing some examples tomorrow with code. But this is like a high-level understanding with like some conditional statements and such. So for example, the user wants to make a Lightning address payment. They click submit, right? Let me pull up the other diagram. So they click submit. So you're checking these things on the back end. So is the amount greater than or equal to 10? If it is, then you can check the validity of that Lightning address. If it's not, then you can return an error back to the user. If it is valid, then you can actually fire the payment to the Lightning address, and then you'll get a response as well as like a callback or webhook, depending upon the service that you're using, that will tell you the state of that payment. And once you get the state, if it's completed, you can perform like a success action. So if you're building a wallet, you can credit the user's balance. So for example, for e-commerce, you could show like a success message to the user that their tip went through or that their purchase went through, as an example. So yeah, that's some examples of the UX flow for Lightning address. Now, for example, a paywall or purchases with static charges. What does the user experience flow look like for that? If you're building an e-commerce use case, or perhaps you're building like like content monetization, people want to sell access to blogs or articles. This could also be used for like tipping, as an example. You could build out these components where you have like a header. These are the items for sale. You have a navigation bar with your brand, and then you have some cards with the information of the title, the description, and the price. The user can click buy, and then from there, they can be shown like a static charge or LN pay, which is associated with the user as well as the item that they're purchasing. So then if you receive a payment for the amount of 1337 sats, you know who actually paid it. So then you can redirect them and give them access to said purchase. So you can either have the user use their phone to scan this QR code and pay it, or if they have like a wallet like I showed earlier, like a browser extension, you can open it up with the browser extension and complete the payment there. And once the payment has been received, you'll get that callback. You'll know that the payment was successful or not. And you can if it was successful, you can redirect them to give them access to content, request shipping details from them, so then you can sell them whatever or send them whatever item that they had purchased. So that is essentially like how the static charge user flow would work as a paywall. And there's some examples here as well. Let's see. It's like how to handle the static charge payment. So user receives a payment to their static charge. You'll receive a webhook. You'll look up the charge ID. You'll find the relationships to the entity. In this case, it would be a user. And then you would perform a success action. So you could be inserting a transaction. You could be granting a purchase. You could be flashing an alert on the screen like we saw with Zebedee Streamer earlier. It's really like up to you what you want to do with that success action. These are just like common patterns that you'll see with these Lightning primitives. Okay, we'll pause there. Any questions so far? No? Okay, we'll keep going. So then we have, for example, money flowing in. Let's say you're wanting to like build a wallet, as an example, to allow the user to deposit funds, to buy things on your platform, and then to be able to withdraw. So this would be an example of using static charges or LN URL pays to allow users to deposit funds into your platform. So this assumes that you have a user with a balance already. So like the balance could be 0, but you're tracking that balance. So you have like a column in a database, as an example, with balance held as like integer. So then you could have a balance of 0 or 10 or 1337 in this case. And the way that you would do it with Lightning payments to update their balance is you could click deposit. From there, you would show that you would have created a static charge for each user. So you'd fetch their static charge, and then you would just show it as a QR code on the screen, or put it as an href attribute in the button itself. So when they scan and pay this QR code, when you receive the payment, just like in the other diagram here, the payment would be received. You would get the webhook or callback. You would look up the static charge ID. You would find the user that's happening in your database, and then you would perform a success action like update balance and credit this balance, as an example. So then from there, you could show like you received a payment to your static charge QR code, and if they go back, then you could show an updated balance. So in this case, this is an example of a user receiving 100 sats. All right, and then it's pretty much very similar flow for like a profile. So imagine you are on a site like Wavelake where you're listening to music. You click on an artist profile, and now you're seeing their profile, and you want to send them a tip or a zap. So then you can click this zap button. From there, you're shown their static charge QR code. You can scan it. You can pay it. And then from there, when the user actually goes to their wallet, they'll see their balance is updated. So now we're on like a wallet type screen. So you can see that there's like some very common patterns throughout these user experiences based on these building blocks of Lightning that we presented earlier. You can do all sorts of different things. For example, we saw earlier with the presentation, you could build a static charge QR code that is connected to some IoT device that then feeds, an animal. So these are just like some of the things you can do upon a success action. Now looking at LNURL withdrawal flows, these are like moving money out of a wallet. So wallet's moving, funds are being debited from your account. So the money's being taken out rather than coming in like the other examples that we've seen. So for example, you have a wallet screen for a user. They want to withdraw, they click withdrawal. And from there, they're shown this QR code. And this QR code is LNURL. So then they want to take the money out of their wallet. They can click open. You can make a request. Let me take a step back. So when they click withdrawal, what you're doing on the back end is you're making a request to an API. You're asking for a withdrawal code. You get a response back. If the response was successful, then you can render it in the page as a QR code as well as a button. So then the user can scan this QR code or open up this wallet, open it up with their preferred wallet, and then click confirm, and then they've received their withdrawal request. This is what we saw earlier when we talked about selling Lightning vouchers. This is when I was on the lightning.gifts page. I clicked the QR code, the button, and then I was able to transfer from that QR code into my Zebedee wallet. And then we have some similar examples for invoices. So if you wanted to build an application that paid invoices, you could have them paste the invoice or type it in, whatever. You can click the paste button or click the input field, paste it, hit next. You can use an API to decode it, or if you have a library, you can also use that. Then you can show the user the details of the invoice if it's successful. As an example, you can show the expiration time, or if it's not valid for whatever reason, you can show an error message back to the user. So then they know what happened or what went wrong. And then you can hit pay. If the payment is successful, you can show a success toast, and then they could do another one if they wanted to, so long as they have funds in their wallet. Or if something went wrong, you can show an error on the screen. That way you can inform the user what's happening with your application, where things are going wrong, where things are going well, and kind of guide the user along the experience. And then next we have like a paywall purchase with an invoice, so it's very similar. This time you'd click buy, you would make a request to the API. You'd say, give me an invoice for this amount with this description. And you can even pass in internal IDs. So you could say like for this user ID. So then when they pay it, you know who to relate it to, who to look up, and what information to look up in your database and to create a new record within your database. So you can scan this QR code and then pay it. Or you can open it up in the wallet. Upon it getting paid, you know that you're getting a callback or a webhook to then say, okay, this is good. Now I'm going to send you to this content page that you paid for, or I'm going to send you this item, or whatever use case that you're trying to build. It's almost identical too with one additional step for tipping. So if you wanted to use invoices instead of static charges or LNURL pays, you could also do that as a replacement. It's a little simpler to do, a little bit simpler to integrate. So then you could click tip as a user. You would enter the amount. So in this case, I'm going to enter in 10. I'm going to click next. And then on the back end, what the server is doing is it's hitting the API again. It's saying, give me an invoice for this description, for this amount of Bitcoin, and with this user ID. And then when you pay it, then it'll return an invoice. You can render it on the screen, and the user can open it up in the wallet, or scan and pay it, and then you can show a success UI if it was successfully paid. Otherwise, you could return an error. So that's pretty much like all the different user experience patterns that you'll see within Lightning and Lightning applications. You can build this in for whatever essentially you can imagine. You can think is, are you trying to receive funds? Are you trying to pay out funds? Am I trying to enable tipping for particular creators? Am I trying to build an e-commerce use case? And you can look through these designs and figure out which solution works best for you. And then you can have some integration hints for the business logic of the server. And you can scroll through here and see like the exact flows. So you can do like user wants to create a withdrawal request, so you can hit the API for the withdrawal request. And upon doing that, you could perform some sort of update like debiting the user's funds, recording the transaction, or rendering it on the page. You can print it out on like a little receipt if you're trying to sell Bitcoin. And then upon it expiring or it completing, you'll be able to then determine like what you want to do next. So this will walk you through like step by step at a high level for any sort of API endpoint, whether you're using LM-Bits with your own infrastructure, you're using a Lightning service provider like Zebedee or Ebex or Galoy as an example. Yeah, so these kind of general high level explanation on how you can implement these things. And then the links are here as well. And then building a template, so we can go ahead and show what that would look like using VS Code and Bootstrap. So let me delete this folder. So then I'm going to create an index file. Let me go back to the documentation. So this is what the Bootstrap documentation looks like. You can copy it. You can paste it into VS Code. We can add it before the closing of the body tag. And then we can also add the Bootstrap before the closing of the head tag. And then let's check this out. So then we got like somewhat of a stylized hello world. We can check out, let's see, where are the components? Containers. So you can see some of the container information. So if you're familiar with CSS, you can see the different breakpoints that Bootstrap does for you automatically, so it'll be responsive. So I'm just going to copy the general tag here. We can get some general rows and columns. And the tutorial that I linked will cover like all of this information as well. All right, then let's check the design. Let's build this. So we need the Lightning address payout. So we'll put it within the H1 tag. Then we'll have columns. So now we need the forms and buttons, so we can get the form overview. We can refresh the page. Looks all right. We'll put the H1, this element. We can change this to Lightning address. We can delete these because we don't need these sort of input fields. Amount. comment. Whoops. And it was really that easy to rebuild sort of the design that we had here in Figma. So now what we could do is take this design and we could integrate an API to be able to handle said payment. So how much time do we have left? We have we have time? All right, cool. So why don't we like build an example then using like the Zebedee API. So now we have this sort of template. We can build it with Django. So Django docs. Anyone have any questions about Bootstrap so far or anything that we've covered? Yeah.
In every Bootstrap implementation, I have things like disclaimers or some sort of warnings. They always recommend to download all the components instead of only using the link tree. So I wanted to ask you if there's like a significant difference in two ways of using it.
So for like Bootstrap as an example,
Yeah.
so like instead of using the CDN, Bootstrap CDN versus like installing it as a package, I think you for like a proof of concept or MVP, it'd be fine to use a CDN, but anything that you go to like production with, you'd want to use like an installed package on your computer locally, just to get some performance gains. And then you could also like make sure that it's the correct version as well. Because then if they make a breaking change in like a future version, you're pulling the new version, but your application is using the old version and set up for the old version, then it could break something within your code, whether it be your template or a backend. So that's how I would suggest that. I don't know if everyone else would agree with it. But I think for proof of concepts and building something fast, using the CDN is fine. Okay. All right, so let's add some Lightning capabilities to this. Let me find where. So quick install guide. So then we'll install Django, writing your first Django app. So here. And I'm just following the Django documentation. For those that are not familiar, Django is a web framework that uses Python. So I'm just using this web framework to build something quite fast. I like it a lot for MVPs or minimum viable products. So like whatever the minimum functionality is needed to build like a web application and then get users to start using and testing it. And it's like quite stable as well. So I really like this personally. So here we'll run Django start project my site. It'll create a file. Let's see. All right. I don't know why this hasn't refreshed on my computer. I see the. Let me reopen this. That was weird. There we go. So now we have my site. We can cd to my site. Now let me enlarge that so everybody can see better. So now we can run the server. So now we have like a web server installed locally on our computer.
What kind of web server you use?
This is a Django web server. I think it uses Nginx if I'm not mistaken. So then I can create an app. We'll call it LN app. I'm just following the documentation along with it. So then we can write a view. So we'll then create, let's see, LN app. We'll import the libraries. So now views are where you manage the backend and where you can render these templates and handle some of these experiences. So you can handle like post requests, get requests to the web server. You can get like the different properties, and I'll show you some examples. So then we're going to create like a routing file called urls.py. And then we're going to render this index file. And then we can go to the settings file, which is kind of like the routes for your entire application. Then we can put the name of the app here. And we can include path. That's fine. Oh, here we go. This is what we need. All right. Then we can run the server. So you can see with this views file, I essentially am just returning an HTTP response of 200 back to the person that's viewing the application. We don't need a database, so we can skip over this section here. But if you did want to add database capabilities, Django does support that out the box with an ORM. So then you can easily create items in a database, get items in a database, make different models, so on and so forth. And the documentation covers this quite nicely. So let's see. So now we're going to go ahead and render the template that we created. We don't need the context just yet. And we can create lnapp.index.html. We're going to create a templates folder, which houses all of the different HTML files. We're going to create one for lnapp, which is the name of the application. And then we can move in the index.html file. Now let's take a look at our web server. lnapp, let's see, template does not exist. Let's see. Must have messed up the directory. So let me see. Render.index.html. So polls.html. Let me see. Where I went wrong with that. Oh, I know why I didn't add the application to my settings file. Django app to settings.py. All right, there we go. Now we can render the template. And you can see that we have the same fields here, the lightning address, the amount, and the comment. So then we need to give these names so we can fetch some of the properties. So we'll give this name equals lightning address. So this is how we will get it from the post request, the properties that are coming in from the form, and then make an API request. Amount. And then comment. And then slash. So we'll perform an action and the method will be post. So if the request is .get, we can return the rent this page, or perhaps this, else. So this is where we will add calling a pay to lightning address. So we'll just print the request.post. And the page should still render. Yes, it does. Still gives us a 200 response. So now we will go to the documentation and we will fire a send payment to lightning address. So this is our documentation page. I'll be covering this like more in depth tomorrow and showing an example of our SDK. But here we can pull in python.request. So we're going to import these modules to make a request to the API. And this is how we will go about doing it. We can delete some of these comments. So we can do request.post amount. We can get the lightning address. And then we can get the comment. I believe that's what we named it. Yes. And then we can actually make a request to the API endpoint and post it. So we can make payments quite easily. All right. So now we need to get the API key. We can get from the dashboard. So this is used for authentication. So then it knows which wallet that I'm trying to send from. All right, now let's try it out. We'll send the request. Oh, we forgot the CSRF token. So Django comes with a lot of security features already built in, so we can pass in a CRF token. All right, so let's see. So we got an error, but it was because I didn't return a response. So you can see the payment actually did just go through. So now we just need to return a success message. So we can ask like how to add messages.success to Django. We can look at some documentation that's available. All right. So let's add some additional code to handle the success notification. So if response.data.success, and we can print out the response to make sure that we're getting the right information. Data. Then we can create message where we have your payment was successful. else message equals your payment did not work. And then we can return back another render template. So we're going to create a Python dictionary or an object that contains message. And then we can render it in the template. So that's kind of one nice thing about Django as well. It's similar to other web frameworks where you can just pass in a variable into the template to render things dynamically. Okay, so then if message exists, now we can go back to Bootstrap and get a pre-built component. Let's see, alerts. All right, so if there is a message, we're going to go ahead and display it to the user, is essentially what this code block says. And then if there's no message, then it's just not going to render it. Now we can refresh. Let's see if this works. No, response has no attribute data. Let's see what we got back. Oh, it didn't actually show me what the response was. Let's just comment this out for right now. Oh, I see. Response. Post. Submit this payment. Oh, we didn't save. Take a look at the response. I just want to see what's coming back so that I know what to show to the user. So you can see the payment was successful. Let's see. I think I need to do .json if I'm not mistaken. All right, so now we're getting back the shape of the data. So this is what you actually get back from the API. So we can kind of talk about that for a second. You can see that you have success is true. You can see that you have all of this data here with an ID, the fee, the amount, the unit, which is in millisats. So this is 10 sats. You can see the invoice, the pre-image, the wallet ID, the transaction ID. If you have a callback URL, you can also see that. So that's what we were talking about earlier. When you send a payment, you'll get notified whether or not the payment was successful. And then you have the comment, the time it was processed at, created at, and then the status. So then we can see that the payment was done. So now we can check here based on response. If response.data.completed is equal to completed, then we'll show your payment was successful. Otherwise, we'll show your payment did not work. And then we'll add the context back. So let's try this again. So 10 sats with the comment hello. We'll submit the payment. And let's see, we have no attribute data. Oh, I see. I'm too used to writing JavaScript now. This is what happens when you context switch a lot. Now let's give this a go one more time. Okay, we got a key error when it came to data. Let's take a look. Why? All right, let's see what error we received. No data, response data. So let's take a look at the object that we received back earlier, and then we'll basically be done with the whole application. So this is kind of like what the iterative process would look like for building your own Lightning app. You kind of just like follow the basic business logic, build out the template, and then begin using the form data to then make requests to the API. So let's see. Okay, we'll print out the response. Oh, I ran out of funds, so that's why it was giving me problems. So then we can transfer. Okay, now we have funds, so we should get back the correct information. Okay, let's try this one more time. Let's see. Oh, I put the wrong property. There we go. So now we can complete the payment and then determine whether or not we want to show a success message. In this case, the payment was successful. You can see that I received the funds just a second ago for 10 sats. So that's kind of an example of how you can take these designs and then integrate an API. You can use the data that you're receiving and then render a specific Lightning Network user experience. So you can do this not only for Lightning addresses, you can do this for the paywalls, you can do it for tipping, you can do it for e-commerce, and this is like kind of the iterative approach that you would take. And you can use this not just with Django or Python, that just happens to be what I'm most familiar with, but you can do this with JavaScript, you can do it with Ruby on Rails, whatever web framework or web application stack that you prefer to use, you can do it with. So I'll kind of pause there. I see we're at like 45 minutes. Any questions?
Have you even used Flask?
What's that?
Have you even used Flask?
Oh, Flask?
Yeah.
Yeah, Flask is great. You could essentially do the same exact thing with Flask.
Which is the difference between Flask and Django?
That's a great question. So Flask is a bit more like lightweight. So then it doesn't come with like a lot of the security things like the CSRF token to prevent like cross-site scripting. It does not come with like authentication out the box, whereas Django, as an example, you get connection to the database and you get a full user model. So you can do login, registration, forgot password, essentially all out the box. Whereas Flask doesn't come with these things. So Django's like a bit heavier, but it comes with a lot of things for free. And then Flask is where you would want to like build something more from scratch, more malleable, more customized is how I would look at it.
If we not have this UI you use, we can run the commands of Django in the console.
Could you say that again?
If we not have the UI that you use for Django, we can run the commands in the console, or we need a UI.
You could run this in Replit. So as an example, there's Replit that you could use as an IDE. You can create templates. You can, and I'll cover some of this stuff tomorrow. I didn't want to go too deep into integrations. Tomorrow we'll look at the SDK and the API a bit more closely, and then we'll show some example templates that you can use to get started quickly with Django or Next.js as a starting place. And we'll also look at some more of like the playground to see like some example code, so on and so forth. But I mainly wanted to show the designs, the user experience flows, how those work, along with the integration hints, and then show an example of like what that would look like to build the template, to then like actually handle the experience and to create it for the user. So I don't know if that answered the question. Now, with Zebedee, you're not able to connect it to your own node, but the experience would be very similar if you were to use like LN bits as an example. So if you're able to connect LN bits to your own infrastructure, you could use the APIs provided by LN bits to be able to build a very similar flow, if not identical flow, to what I just showed here. This just happens to be what I'm most familiar with.
TDD uses real Apache, or it's still possible to use Reckless or something like that?
Uses real sats. Yeah. All right, with that then, we can close it out. Thank you very much. I hope you all enjoyed this. All the files are in the Telegram.